asymptote, it's something that gets closer to zero but never touches it. And once it gets to zero, because like that x value divided by zero is undefined. So is there any like real life scenario which can be graphed in a form of an asymptote? Like so like in a linear graph or whatever, like imagine like a cubic, like a degree three. Okay, I'll just draw it. Am I able to
Okay, I'm sending you the board
am
link.
I
You
able
can
to annotate?
join. Wait, I'm sending you the board link. You can also join this one and you can write here.
Nice. What's it called?
It's a concept board. You
Okay.
can join as a guest.
One second.
No.
Concept board. Guest access. Name. Tush. Red. Okay. So so like you can kind of say a graph like this that uh so you can kind of say like a graph like this is like a profit and loss thing
Mm-hmm.
where at a certain point after x is less than or more than one, then it starts depreciating heavy. So like you can use a graph like this to explain like a profit and loss situation. Is there like any like real
Asymptote.
life situation?
Yeah,
Yeah.
we can say, even if we are doing a business, so we have a profit and loss, let's for profit and loss example. So there is a critical point after that, like even that is a critical point in profit and the loss. Like let's talk, mostly it happens in loss. If we reach to that point in loss, we never come back from that point. Like if we touch the zero line, maybe if you know about cryptocurrency, recently
It
many
went down.
accounts, yeah, many accounts liquidate. What's the meaning of liquidate? Like if the
You convert to
like,
cash.
yeah, it never get back. Like the
Oh,
price is
so it's like a in finance we call it like a sunk cost. I don't
okay. I'm not familiar with it. Like if after a point we never get back. So
know. Okay.
like it's simple example, if we have signal tower, let's suppose mobile signal tower we have, and if we will move far away from it, signal tower,
Yeah, yeah, yeah.
if we'll move away from it, so signal strength will be weakened, right?
Mm-hmm.
But if one point will be reached, after it will be totally lost. Like we will never get the signal. And
Mm-hmm.
same debate, if we are reaching to this side, so if we are moving closer, one point will come, so signal will stop increasing, means stop increasing, it will be infinite, right?
Mm.
So that is our
True, yeah.
asymptote. That you can say that point is our asymptote. Like
Strongest connection.
yeah, strongest connection, and after it's not increasing, it looks like it is increasing but it's not increasing, so it will be our let's suppose if on in our phone we have a four signals, bandwidth is in bandwidth or something, I don't know in that much detail, so it will not increase that much limit, so it just fix and that's all.
But then my question is that like this is the this is the peak of the strength. This thing right here. But
Okay.
then when you're going this way and you surpass this part, so say this is like 200 meters, right? When
Mhm.
you walk past 200 meters, then the connection is dead.
Yeah.
So wouldn't that technically mean that it's touching zero on the x-axis after a certain point.
Yeah, that's true.
So then that means that there is only a, a vertical asymptote.
We cannot say this is a vertical asymptote, but if we implement the same example towards this side, to
Oh,
the
okay,
strongest
okay.
connection. Yeah, if same thing you implement on the strongest connection, like if you are moving towards the tower, so there will be a point reach. After it, it looks like it's infinity, maximum, right?
Hmm.
Even though you
Maximum
are
number.
even though you are moving towards that point, even though let's suppose this is a 5. Okay, this is at location 5, x5. So you are moving towards 5. So when you are moving towards 5, so if you will be here, so it will be maximum value,
Hmm.
highest value we will get here. Does this make sense or not? So our
So,
tower will be asymptote.
so then it would go like this, right?
Yeah, exactly. So here we will get the
So,
strongest
but but this
signal.
only makes sense if like this signal is unlimited, right? Like unlimited
Yeah,
bandwidth.
exactly.
Oh, okay. All right. I
Th-
just wanted like one
Just this
question like that.
this example, it's an example. Like definitely we don't have infinite bandwidth. It's just example to understand.
Oh yeah. Thank you. Thank you, Mishra.
Okay.
Thank you.
Okay. Now let's talk about this one. So yesterday we discussed. I already explained like what's the difference. So in this one there will be two vertical asymptotes. Like when this function is in this one we cannot include 3 and -3. So in this one we will get two asymptotes. That's the only difference we have between reciprocal of linear expression. We have a function reciprocal of linear function. In this one we just have one vertical asymptote, and in reciprocal of quadratic function we have two asymptotes. Okay,
Yeah. Okay.
so let's discuss the questions from here. You have this book, right?
Yeah.
157. So we will discuss the question number 1. In question number 1, what we have to find out?
Horizontal asymptote, vertical asymptote, intercepting integration behavior. So should we start by factoring? Oh
It's
no, you
like
don't have to.
it's almost done, you can say. Firstly, we have to find the horizontal asymptote. Yesterday, I told you how to find the horizontal asymptote. We just have to find out how the function is behaving if the x is approaching to infinity and x approaching to minus infinity. Like our function is approaching to which value? Our y is approaching to what? If x is approaching to positive infinity and x approaching to negative infinity, our y is approaching to which value? So that will be our horizontal asymptote. Okay. And how we
Okay,
can find
okay.
it out?
Yeah.
We will just like put a bigger number in it, like 1,000 in positive, and in negative you can put -1,000, and then check out the behavior of the function. Function is approaching to which value. So that will be our horizontal asymptote. Okay.
So can you give an example
Like if we are replacing infinity, we are thinking like it's 1,000, right?
f of a
So
thousand
what will be
equals 1/1000 square?
1,000 square? So that will be 1/1,000,000, right? Which means we have
1,000 times 1,000, six
0
zeros. Yeah. I mean,
0.0001. Okay. And if we will replace bigger number, more bigger number, like 10,000, so what will happen?
wait, so when x equals 1,000, then y value is 0.0001.
Yeah. And if it,
So on the graph, doesn't that mean that it's it's kind of like quadrant here? Let me just try to draw it.
when thousand
So
thousand here, so its graph will be like this.
yeah,
Let's not
exactly.
talk about this one. Let's just start. It's going to this side, like moving closer to zero, right? But it will never
Mhm.
gonna touch to zero.
And we picked a big number because that
Get more
defines this
accurate.
better.
Yeah.
Okay.
If you will pick like one or two, so then maybe we will get error in it. Like if you are replacing one here, so according to one, so we are getting one, y is equal to one, but that's not our horizontal asymptote. We have to just check
Yeah,
it out
exactly.
about which value our function is converging when we are when our x is converging to when our x is approaching to infinity. Infinity means a very big and bigger number. So how our function is behaving, to which number it is moving, to which number it is approaching. So our function is approaching to zero as x is approaching to bigger and bigger number, right? We will check the same behavior in
So
the negative.
so if you picked negative 1,000, how much is that? One
It will be
divided
the same.
by it will be negative 0.0001.
No,
How much would it be then?
it will be positive because of square. Look, if we are replacing x x negative 1,000, so what it will be? Wouldn't we just 1 over negative 1,000 square? Because of square, this negative will be turned into positive, right?
Oh, yeah, yeah.
It will be 1 million again in the denominator, but still positive. So it will be the same value, 0.00. So then,
So then that way.
yeah,
Okay.
that's it. Do you understand it? So our horizontal asymptote is, where is our horizontal asymptote?
That's is it zero?
Zero. So that's the answer for A par.
How would you show that it's zero? Like how do you
We will
just
just show this like as x approaching to infinity, our y is approaching to zero.
mm,
And you have to do this work, but just for your own understanding, for yourself. You just have to write these things. As x approaching to infinity, y is approaching to zero, x approaching to minus infinity, y is approaching to zero. So that means our horizontal asymptote is zero. That's it.
okay.
Okay. There is another way as well for our own understanding, like to find the horizontal asymptote. And what it is, you can directly just replace x with infinity and then check it out which to which number it is approaching. Definitely 1 over infinity square means 1 over infinity, and 1 over infinity means 0. So it means that our function y is approaching to 0 as x is approaching to infinity. Same debate
Okay.
on negative.
That mathematically makes sense too.
Mhm.
Okay.
We don't have to basically, that's just a trick. Not we cannot use as a verification or as a proof. We cannot use.
Mm, okay, okay. So that's the horizontal essence.
Yeah, vertical asymptote is
Or-
way easier than horizontal asymptote. We just have to find out zeros of the denominator.
So this one it's 1 over x squared, it's x times x 0.
So we have to find out on which values of x this denominator is equal to 0. So it's only 0. In this one, we just have one vertical asymptote, that is at x is equal to 0. So horizontal asymptote is at y is equal to 0, means on x-axis. Okay, y0 means x-axis, and this x0 means y-axis. I hope you knew about it. Does this make sense for you?
Hold on. X equals. So this y equals the x-axis. I don't understand what like y equals 0 on the x-axis means.
Okay, what's the value at this point of y? Not x. Definitely x will be negative something like -3, -4. But what's the value of y at this point?
It's like let's just say 0.001.
No. Y. Exactly on this. Isn't this one will be 0?
Wait,
Y is
are you
changing
picking an x value? What's the x value?
on x-axis. I select this point on x-axis. I'm not taking this point on the curve. On x-axis, Cartesian plane, like x-axis and
Yeah.
y-axis, definitely.
Mhm.
So at this, what's the value of y? Y is 0. Y is increasing vertically, right? 1, 2, 3, and up to so on. And down we have -1, -2, -3, and -4 up to so on. This is very basic. I think you are not just picking it up. Okay, look, this is 0. What's the value? Okay, what's the value at a region? Both x-axis and y, both x and y are
0.
0. X is increasing towards right, like we have 1, 2, 3,
Positive infinity.
4. Yeah, it goes to positive infinity, and to this side it's negative infinity, -1, -2, -3. Okay, if I select this point, let's suppose this point. So approximately what are the values or what are the coordinates of this point?
2, 2, 2.
2, 2. And if I'm selecting this point, approximately this point, what are the
3,
coordinates of
1.
3, 1? Now, if I'm selecting this point, let's suppose this one.
3.4, 0.5.
Say it again.
Or 0.5.
4 and 0.
Wait. This one?
Yeah.
Oh yeah, it's 0 because it's on the x-axis, right?
Yeah.
So
So if you will pick any point on x-axis, what will the value of y?
0.
0. That I just trying to say, like on x-axis, on whole x-axis, what's the value of y?
Okay. All right.
Okay. And same debate on whole y-axis. On
Then
whole
x
y,
equals 0, yeah.
x is equal to 0. That's it. That I wrote here. Y is equal to 0 means x-axis. Our x-axis is a horizontal asymptote, and our y-axis is a vertical asymptote.
All
Got
right.
it?
Mhm.
Okay, next. It's C part. Intercepts. This is easy to find it out. Can you please tell me what these are?
The y-intercept.
Both. We have to find both. And if we don't
So
have, maybe we don't have the any.
I don't think we have an x-intercept and we don't have a y-intercept either, no?
Yeah, yeah, exactly.
Because horizontal asymptote at 0 and
Exactly.
vertical asymptote at 0, so it
We
never
don't have any.
touches.
Yes. And the good thing is that I have answer sheet as well, so we can find we can verify our answers. Let
That's
me
good.
let me paste the answer sheet here. 1 second. It's 3.2, chapter 3, 3.3. We are doing question number 1, right? 1 second. Question number 1, investigate. Investigate. Wait a minute, please. 157. Hmm. We don't have the answer for this. 157, 164.
150. It just disappeared, huh? What the fuck? It's okay, like, I don't think we need it.
Maybe it's because this is an investigate, so that's why. Even we
Oh,
don't
it's not
have
a
for
real question.
158. Yeah, the real questions are these. These are practice questions. Okay, we must have to start
So we
from
can do
there.
that.
Yeah, so we can start from here. So these are the real questions. Even in this, we have the same thing, I think. Let's check it out. Okay,
All right.
here we have a different kind
So,
of function, like copy and complete the each table to describe behavior of the function as x approaches each key value.
so we have two vertical
Okay.
asymptotes at
Yeah.
3 and 1.
Okay.
Uh, how do we tell
Okay. If we are three negative, can you see here? What's the meaning of negative? It means that we are
on
approaching
this
to
side,
three. Yeah,
the
it's
left?
2.999 or something. So we are approaching
Hmm.
to 3 from left side, from negative side, I mean 2.99. So if we replace 2.99 here, what will happen? 2.99. This
2.99 minus
definitely, this thing will give
0.1.
us a positive value, right?
And this one negative.
This one negative. So if this is negative, so
0.1 times 1.9 is negative 1.9.
it will be negative infinity, right? Like if I will take more bigger 2.99999, so it will be 0.00001. When we'll divide 1 with 0.0000001, I mean
Oh, yeah,
negative
yeah, yeah.
0.0001. So what it will be? It will be means negative infinity, right? So it means
Hmm.
that as uh, we are approaching to 3 from this side, so it is like this. Does this make sense?
So then what about this one though?
Yeah, we will test this one as well. So if we are approaching to 1 from positive side, this is positive side of 1, right? Okay. Positive side means if we replace here 2 point, sorry, 1.1, 1.1 or 1.00001 something,
Hmm.
1.001 something. So what will the answer? Definitely this one will give us 2 point something, means approximately we will get 2 or something answer from here. And it will be in negative, right? And
And
what
then
about
the
this
other
one?
one,
This one will still positive and it will be very small number. Small numbers because we are taking x 1.0000001. So what will be the
a
answer?
negative 2,
It will
1
be,
over negative 2.0001.
no, not negative 2 point. Because of multiplication, it will be, if we are getting here 0.00001, when it will multiply with negative 2, so it will negative 0.00002. That's only the difference when it will multiply by 2. Do you understand what I mean? Or should I have to explain?
Wait. 0.01 times negative 2 is 0. It's negative 0.02, right?
Yeah, it will not
Okay,
be,
okay.
you are saying 2.0. It will not be
Oh
2.
yeah, my bad. My bad.
Yeah,
That's not
you are
sense. Yeah.
doing. So if again same debate, if we will divide 1 with this kind of number, very small number, so again we'll get negative infinity. Negative infinity means it will goes down like this. Okay, is
And
this
then I
making?
assume
No, we
some.
cannot, we cannot assume. We must have to verify. Okay,
Okay,
let's check it out. So same thing, same function, but this time we are approaching to 3 from the
positive.
right side, means like 3.001. So
Four.
the same function, we have 3.001. 0.0000001, let's suppose, minus 3. Okay, and then we have 3.0001, again means very small number, very close to 3. Okay, even
Okay.
maybe these zeros are not same. Minus
So
1.
we picking four is not a good number, right? It has to be close to three.
Yeah, close, very, very close to 3. Like if you are taking 3.1, even this is close, but this is more close, right?
So more exact. Okay.
So
What
like
is that? Three
we will get
point
more accurate answer. Okay, what will we get from here? We will get 0.00 something.
one, and this is 2.0.
Just take, let's take 2 something. So if we multiply, what will the answer? It will be 0.00002, right? Something.
Yeah, yeah, basically, yeah. So then,
1 over positive 0.0000002. Whatever, either it will be 3, 4 something, but it's gonna be very small number. So if 1 will be divided,
so from the positive side on the right of three, when x values approach uh three from the right, then the y values will be like an
positive
asymptote, get closer to zero.
positive infinity, it is reaching to positive infinity as we are reaching to this side. So it is reaching to positive infinity like this. Do you understand? So its graph will be, I'm just guessing like it will be like this. So we will get this part. How will verify this part? We will put a very big number after 3. Like if we will replace here
Mhm.
1000 or something. So how this function is, to which number it is approaching? I think it will be approach to 0.
Infinity,
It
positive
will,
infinity.
no, it will be approach to
Oh
0.
no, 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 yeah, 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 zero. Yeah, yeah,
Like it,
you're right.
fine. If we are replacing x here 1000, so 1000 minus 3, that will be 997. 997 multiplied by 999, because this one will give us 999. Are you getting what I'm
Huge
saying?
number.
Yeah, and when we multiply 997 with 999, so it will become more bigger number. So 1 over bigger number in million. So what answer will it will give? It will be 0.00000, very small number. Means it is converging to 0, right?
And and it's positive, so it's above
Yeah.
y-axis. Okay.
So we have to write here f of x is approaching to, as 3 approaching to, as x is approaching to 3 from negative side, it was approaching to negative infinity. Yeah. 3 positive,
So
it was
as
positive infinity.
three as x approaches from the left or from the right, always.
Right.
What's the rule?
From the right. 3
So
positive means,
when x values approach, then the y values are going up, so positive infinity.
mhm.
And for 1 minus, we input a number, so 1.
We didn't solve this yet.
Uh,
We didn't check, like, is
so
this like this, or either maybe it's like this. So we have
so
this
we
both.
input a value, right?
Yeah, we will check it out.
1.0001.
No, it means that if you are replacing 1.001, it means that you are approaching to 1 from the right side. We have to replace 0.99, 0.00009.
Oh,
No,
less than 1. Right.
yeah,
Less than
very
1.
close to 0.9999, even not 0.00. So that's so far. We will replace 0.99999, very close to 1, and 0.9999 minus 3. So we'll check
And
out the
then
thing. This answer will be
this
negative
is
2 approximately. Let's take negative 2 something. Like it will be 1 point something. No, it will be, no,
1.111.
no, it will be 2.0000001,
111. Oh, zero, zero, one.
right?
Because it's 99. Yeah, yeah, yeah. Then that
If,
fits.
if you're not getting it, you can put
3.
in calculator.
No, no,
Okay.
no. I get it. Because 0.99 plus
Uh,
2.0001 will make 3, right?
and what will the answer? This one will be negative 0 point in negative,
Zero
because 1
point.
is bigger. 0 point zero zero
zero
zero
zero
zero zero
zero
zero
zero
zero
zero one.
one something. So when we multiply negative, negative will be turned into positive, right? So 1 over, and
0.0000.
it will be a very small number in positive. So again, um, we will get positive infinity, right? Means it's
Because
approaching.
it's plus value. Yeah, so this part is
Again,
over
yeah,
the y-axis.
yeah, and I'm pretty
And
sure
then,
if we replace negative value by big like negative 1,000 or negative 2,000, so it will be approached to zero again.
oh, so then this looks like, this basically looks, it looks like this, right? But these asymptotes are at 1 and 3, so they're on this side.
Yeah,
But that's what
they are,
a reciprocal quadratic looks like,
yeah,
right?
it is. They are only changing
Okay.
the value, so asymptotes just change. Okay.
Okay, okay.
And maybe in some cases we will get like this one up here, this one like this. So it depends. So we must have to check if they will change the sign. If they will change the sign, like instead of x minus 3 we have x plus 3, so its graph will be different. If you want to do a quick example of it, we can do on Desmos graphing calculator, because if this took approximately 10 minutes to draw the graph of single
Yeah.
graph, so we have to save the time, so we can just use the Desmos graphing calculator, and from there
No,
we.
no, no, it's fine. It's fine. I understand
Mhm.
if you wanna
Okay.
efficiently.
Okay, next. So we have to write now here. So as this one is positive infinity, we have to complete this table. And so it's negative
And
infinity.
then on the right of one, the values are going down, right?
Yeah,
Negative
yeah,
infinity.
we calculated before.
So then minus infinity is to this side. So
Yeah,
from 1, the x values are going to 0.
0,
And then on the right of 3, going towards infinity, it's the same thing going to
0.
0
We
because
didn't test
this
this
is going
one.
to 0, right?
Yeah, we didn't test this one, but we test this.
But you don't have to test these two, right? Like you can,
Yeah,
if you know all of these, you can just tell, right?
exactly, exactly.
All right, all right.
But you must have to check. Like you don't have
Yeah.
to guess. You must have to check in your head. You don't have to show this whole calculation. These whole things you have to do in your head or in your rough work. Okay.
Okay, can I do this one real quick?
Okay, sure.
I'll try to do
Sure.
it quickly.
Sure.
Uh, x minus 5, it's plus 5. And sorry if I write untidily. I'm not good
No,
at writing with the
it's okay.
mouse.
Yeah, no. Fine.
And then this is minus 4.
Mhm.
So pick a number. So minus 4, it's on this side. So it has to be close to minus 4, but very small. So minus 4.0001 minus
You
5.
made the mistake. You are
I did.
taking minus 4 plus. You
Oh
are.
yeah, yeah. It's less than minus 4. So
No, 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 no.
3.99.
Sorry, sorry, sorry. I was on mistaken. You was right. Yes, it's you are doing this one, right? Yeah, it will be negative 4.001. So this side will be
Oh yeah, you're
3.9.
going 5. Yeah,
Yeah,
it's bigger. And then minus 4.0001 plus 4. So this is going to be like 0, negative 0.0001. And this will be
negative 9, we can say.
minus, yeah, negative 9. And then negative 9 times 0.0001 is just 0.0009.
Be very careful with their signs. Yeah,
And that's
positive.
positive, right?
Yeah,
So then it's over, and then that's going like this.
yeah.
So
Again, this.
this one, it's this.
Mm-hmm.
And then minus 4 plus, so this, so anything in this side, so 3.9, negative 3.9999. Can we do that?
Yeah,
Negative 3.999 minus. I'm just gonna do three decimal place.
Oh, sure.
Negative
It's just
three
for our
point.
understanding. Okay.
Yeah, and then uh negative 3.99 minus 5 is what? Negative 8.9999. I
Yeah.
right?
Yeah, yeah, that's true.
99, and then this is like 0 point. No,
Not 99 will be 0.000001.
1. Yeah, you're right. 0.0001. And then this times this is just negative 0.0008 something. So these values are less than minus, and then it's getting closer to. So it would look like on the graph. Is it this? Am
Yes,
I wrong?
it is. Because you are escaping 1 over. This thing is in the denominator. Keep in mind. Like 1 over minus 0.00008, right? You are
Yeah.
just solving the denominator. So 1 over this thing means minus infinity. Like it will be infinity means very big number, like a million, maybe a 10,000. So if you will take more smaller number, more closer to this, it will be more bigger, bigger and bigger then. So it is approaching to minus infinity.
Decimals get. Yeah. Okay.
Yeah.
And then this is this, and then 5 minus this side, so 4.999 minus 50. 4.9999 plus 4, it's 8.99, and then these together,
Gonna
so,
be
and
zero
this is
point zero
positive.
zero zero 0.0001. 0.00001. Like as more closer.
Oh yeah, 9999. Yeah, you're right. So then this times 8.9999 would be like 8 over 1. And
Mhm.
then this would be like a very, very small, it would be like 0.000, but it's positive. So, right? And
Wait.
then,
Wouldn't be this one will negative. Oh, this is working. It's gonna be like this. Because this gonna be negative 5, right? So the this answer was negative 0.1.
oh, negative 0.1. And then that
Yeah,
makes the whole thing negative.
it's okay. It's okay.
Oh,
So negative
I gotta
infinity.
use a calculator. I gotta
Yeah,
use
you
a
can
calculator.
use. So that will better.
And then if we know like if we know this part, this part, this part, then like I can prove it. It's just like we know. So then on the left of 5, it's going down. So this right of 5, and then this is going to 0, 0. Okay. Did I make a mistake anywhere so far? 5, positive infinity on the left of 5, negative infinity on the right of
No,
negative
that's
4.
true.
It's negative infinity. Okay.
That's all. And for this
X
one,
plus 6. Do we have to expand first?
no, there is no need to explain it. Okay, as x approaches to -6 from negative side, so it will be negative infinity. Wait, yeah, negative infinity. Even this one will be negative infinity. This one will be 0 and 0.
So for this one, you just do the same rule, right? Pick a
Yeah,
number on the left of -6, so like
Yeah,
minus
but I noticed
6.
that whatever the number you will pick, like whatever you will get here, it will be turned into positive, right? Because of this square.
How big? Square?
Yeah, either it's
So then all the values are over? Oh no, not under.
look, we have to select x close to 6, right? Close to 6. Close to 6 means it's very close. What's the difference between 6 and that number? It will be very small difference.
Difference or addition? Because it's plus.
No, there will be difference always. Okay,
So,
wait.
okay.
It's -6, right? We have to select -6. X must be -6. -6,
0.0001.
yeah. -6 needs to be approached from the side, so it will -6.00, like this. So definitely,
Plus, oh, and then that's negative -0.0001
yeah,
because,
yeah.
and then 1
So make
over
a square,
negative 0 point is negative infinity. Oh, okay, okay.
so
So then
negative.
it's going down. Oh, okay.
It will be like this, and it will be like this as well. Okay,
All right.
but in the book they are doing with another method. They are using the slope method, but I hope you understand this method.
No, 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 no. We don't do the slope method, no.
Okay,
This is the same method we use in school, so it's good.
okay. What next we have? Let me press the next thing. 1 second, please. Okay, next question number 2 is it's opposite. Like the graph is, I think, given to us. We have to identify it.
You know, I'll tell you this, the technology that you use is very helpful. It's
Mhm.
very helpful
Okay,
there.
okay. This one. Question number 2. Determine the equation for the vertical asymptotes if they exist for each function, then state the domain. So we just have to find out the vertical asymptote. If they exist for each function, then state the domain. It's very, very easy. I will do the first one and the rest of the question you have to do, okay? Now, within the time. So 1 over x minus 4 square. So what will be its asymptote? Its asymptote will be at x is equal to 4.
+4.
Yeah. And what will be its domain? Its domain will be all real numbers except, or we can say minus infinity to 4. Okay. And then 4 to infinity. This one will be its domain. And if we want to verify the answer, we can verify here. Let's see how they are writing the answer. Yeah, they are writing the other way. Yesterday we learned this method and I was telling you this method to write the domain, like all real numbers, but x not
So
be
that it does
4.
not equal 4,
Yeah,
because that would make it 0, and then that's undefined.
undefined. Yeah. Similarly, what will be the asymptotes for b part, the function that we have in b part?
In B,
Mhm.
negative infinity to
No, firstly you have to tell
2
me the equations for the vertical asymptotes. There will be
2
two.
and -7.
Yeah, what will be the equations?
Uh,
X
x
is equal
equals 2 and x equals -7.
minus, yeah. After that, we have to write the domain.
So the left of 2, 2.000 uh,
We have two
plus
ways to
minus
write
0
the domain. We can
minus
write,
2.0001 minus 9 -1. Okay, so this is negative infinity to 2.
yes. This one will be its domain. Okay, we can write like this, or we can write all real number x belongs to all real number except 2 and -7. Does this make sense?
But isn't that a restriction?
Which one?
X does not equal to a -7.
Yeah,
That's a restriction, right?
yeah, these are the restrictions.
So the restrictions are the domain.
No, this whole thing is domain means what values of x we can replace in it. So we can replace all values, any value we can replace in x except 2 and -7. Except 2 and -7, we can replace any value as a x. We can replace -1000, we can replace 5.555, we can replace any value except 2 and -7. That is its domain.
Okay.
And same thing, we have this sentence is saying the same thing, but in mathematical language. Okay, even this is the same thing. Okay,
Okay.
both are same. And what it is, they are saying we can replace any value from -infinity to -7, and then -7 to 2, and then 2 to infinity. But definitely not -7 is included, not neither -7 is included nor 2 is included. So we cannot replace -7 and 2. Except
Two.
these two, we can replace any. Got it?
Yeah.
Okay, now solve the D part. C is easy.
So x plus 5, x minus 5.
Yeah. And what about C, by the way?
Isn't that x plus 1, x plus 1? So it's only one, right? One asymptote.
No. Wouldn't be +1 and -1? Can you please go back to the slide?
+1, -1. What? X squared plus 1.
Mhm.
So then, but then if it's +1 and -1, wouldn't it
Wait,
be x squared minus 1?
we don't have any vertical asymptote in it.
No.
No, because it never be 0. It never be 0. Denominator will never be 0.
So if you put 1, so 1 square, 1 divided by
Yeah,
2, it's 0.5, 2, 1 divided by 4 plus 1, 1 over 5. Oh,
it never be
okay.
in negative, right? When it will be 0,
Yeah,
if x square will be -1, is it possible like x square we will get,
no.
like we replace something in it and it gives us in negative? It never gives us in negative because of the square. The square will always turn anything into positive. It will always give us positive value. Okay,
Okay.
so that's why we don't
So
have
that's
any
a trick
vertical.
question. Trick question.
Yeah, it is. So how we can find the basically a vertical asymptote? By just replacing the denominator equal to 0, like x minus 2 equal to 0, x plus 7 equal to 0. When here we replace this one equal to 0. So we don't have any vertical asymptote here, because if you are going to find out the value of x, what it will be? It will be -1 square root. Does the square root of -1 exist? No, not in real. That is exists in complex number. And I think you didn't study about complex numbers yet, right?
Mhm.
Complex numbers are above real, like they are superset of real numbers. Like if we combine even and odd, we get the whole number. If we combine even and odd, we get the integers, right? Like integer, you can say superset of even and odd. Even and odd are subsets, means smaller than integer. Are you getting it what I'm saying?
Define integer one more time. Just not any number that's an integer.
You don't know about integers? 0 plus -1 plus -2, like +2, -2, +3, -3.
Oh, yeah, yeah, yeah.
but not 3.5 is not an integer. Okay. So if we disperse this integer into two parts, like 0, 2, 4, 6, 8, so this is a set of even number, and set of odd number 1, 3, 5, 7. This is the, or these are the odd numbers in positive and negative. Even
Prime
positive,
numbers.
no, odd numbers. So we can say set of integer is superset of even. If we compare even set of even number, it's smaller than it. Like integer is bigger than even, right? No.
Hmm.
Okay, leave it this one. Just you just have to understand like this. We don't have the square root of -1. So that's why we don't have any zeros for this function. And that's why we don't have any vertical asymptote for it. Okay, you have to do these questions at home.
You okay? You want me to finish them and give it to you tomorrow
Yeah.
or whenever? K- Tomorrow. Yeah, I have a quiz on day after tomorrow. Can I
Mm,
show? Can I send you these questions? This is a review sheet that
okay.
my teacher gave us. I'm gonna send it over to you.
Okay.
Do you have like an email that I can send it to?
You can send on my WhatsApp number.
It's a PDF. Okay, yeah, sure. I have WhatsApp on my computer.
Okay, you can
Here,
send
I'll
me on
just
my,
screen share it to you for like a second, just to like give you an idea of it.
okay, this is my email ID. You can share him. Okay.
Kaleem. Wait. Kaleem
8230
8230 at
at the rate gmail.com.
gmail.com. Gmail. Let me know if you get it. I'm gonna send it to subject. Yeah, I just sent it over. Let me know if you get it.
No, not yet. Claim 8230, right?
I'm pretty sure I sent it to the right. Kaleem9230 at
Oh, eight.
gmail.com.
It's 82.
8230?
Yeah.
Oh, that's. I don't think there's another Kaleem with 932
Yeah.
with
It's okay.
230, so
It's
who
okay. It's okay.
cares? If they got that email, then good for them. Now they can do advanced functions. Okay, I'll check now.
Yeah.
You got the PDF, right?
Yes. Mohammed, just wait a minute, okay?
Okay.
And Mohammed, until that, you have to send me the pictures of the stuff that you want to discuss.
Okay,
Okay.
can we can do another class maybe tomorrow same time?
Yeah,
Is
sure.
that cool?
Yeah, I think this is
All right.
easy. We can you can easily sketch, like we just have a one vertical asymptote at 1. Let's suppose this is the x is equal to 1 here, or if you are taking this is x is equal to 1. So we have vertical asymptote, and we just have to check it out. What's the behavior of the function as x approaching 2,
One. Oh, the intervals. Okay.
x approaching to 1 from negative side, 1 from positive side, positive infinity, and negative infinity. So these things you need to check for the function, like function is approaching to what. Do you understand
But I'm
what I mean?
guessing it would be one minus would be negative infinity and one plus would
Yeah,
be positive infinity.
yeah, right.
Okay. It's any like one more question.
It will be like this.
When the numerator has a number besides one, is it do I have to do like any other like calculations or whatever? Like is it going to change what we did so far
No,
by a lot?
no. Like if the numerator is 2 here, there will be no change. Only it will be
Same
changed.
principle.
Yeah, same. Only here, it's like the vertical asymptote will be -4. It will be -4 somewhere here. Okay.
And then the two represents is it a compression? Um, what does the two represent again? The numerator?
Yeah, it's like how wideness this graph will be. Wider this
So
graph is.
like what is that vertical stretch?
Yeah, vertical stretch, you can say.
All right. Okay, we'll have another class tomorrow then. Okay. I'll
Okay.
see you tomorrow, man.
Okay, then. See
Okay.
you later.
Take care.
Take care. Goodbye.
Ciao.